This is Midjourney, an imagination program. Give it a prompt, and it gives you an image. Whatever you can imagine, it can imagine. Midjourney is one of the many currently existing text-to-image algorithms, AI models that use neural networks to transform text into images. In its current form, you can use Midjourney through a Discord bot that you can give a text prompt and it will generate a few possible images for you. Then, once it's done, you can select the ones you like and ask it to upscale them to larger, higher quality images or generate slightly different variations of them. I have been hopelessly addicted to Midjourney for a few months now, and the bot is available on my Discord server for anyone to play with. There is something very interesting about generating variations though, which is that you can generate variations of variations of variations. There is no limit. To rephrase it, you are selecting and then mutating and then selecting and mutating again and evolving the images you like the most. You are breeding pictures. So, I opened up a small experiment on my Discord server called Pick Breeder, where we start with one set of images created from a prompt like an organism, and allow anyone to select and mutate the images of their choice. You do this by simply interacting with the bot, and can branch off in whatever direction you'd like. You can also go back in time and select from an older species to create a new branch. The experiment is ongoing and anyone can join, though keep in mind Midjourney only lets you have a limited number of images for free. Many thanks to everyone who used their free trial in this experiment. These images can get a little creepy and kinda gross, so happy Halloween. We can visualize all of the descendants of a single starting image with an evolutionary tree of life, and this is the most extensive tree generated on Discord. You can see how it quickly branches off in many divergent directions, creating all sorts of creepy worms and brains and funky looking things. Many of the branches die pretty early on, but some threads survive for long periods of time, gradually evolving into very different looking creatures with the same ancestor. Now, I had to manually construct this tree, and I've pruned a few very shallow branches and taken out some intermediate steps in the very long threads of evolution, so there are some very minor inaccuracies here. Some of the branches use Midjourney's newer test model, which has a very different aesthetic style, and changes the creatures quite a bit. It even started to generate things that sort of look like hyper-detailed organisms from the Life Engine. It's worth noting that the creativity of this process is still fundamentally limited by the prompt. It's never going to generate a couch, for instance. And it's also limited by the dataset that the model was trained on. Despite this, these are creatures that I would have never imagined and are unlike any artwork I've ever seen. We also tried out different prompts that resulted in some much prettier, less nasty creatures. It took some work to find prompts that were both beautiful and allowed for the most open-ended evolution possible, but I think this one is pretty good. I should thank one of my moderators, Cosmic, who scripted a bot to help download the hundreds of images required to make these trees. The full image files for these trees are available on my Patreon. Another moderator suggested the community try selectively breeding to create some specific animal, so we tried to make a cat. It took a little while, but you can start to see cat-like features gradually emerge. Eventually, we created what I think is the most cat-like one, this kind of weird, kind of cute cat bug thing. Finally, it diverged in a very different direction, again using Midjourney's new test algorithm, resulting in probably my favorite creature, this beautiful, colorful leaf bug. Now, Midjourney is not the only image generator on the market. There is another model called Stable Diffusion, which is open source, meaning I can run it on my own GPU. I can do a lot of things with Stable Diffusion that I can't do with Midjourney. For instance, I can start with whatever image I want, like the purple flower from the Life Engine, give it a prompt, and generate variations. From there, I can evolve my own tree of life. This is a more narrow evolutionary tree as it lacks the community aspect of the Midjourney version, but it still results in some beautiful, divergent branches. I can even change the prompt whenever I want, a sort of different kind of mutation, which drastically changes the evolutionary process. And finally, I can just allow the model to run off on its own without any human selection at all, resulting in a smooth video of evolution. This is a method called interpolation, which I'll explain more later, and it essentially smoothly samples many possible images for a given prompt. Because it lacks the human selection element, it does tend to create some very weird-looking creatures, but in post, I can select the best frames with the most unique and beautiful species, as well as the wackiest ones. Now, the idea of breeding pictures is not new. In fact, it dates back to the 80s, and the experiment that inspired this video was called Pick Breeder from 2008. People were allowed to select their favorite images from a population, which would then be mutated and crossbred into the next generation. It was a community effort that encouraged people to branch off from other images in all sorts of directions, and can still be played to this day. It also used a neural network to generate images, but the network was not trained on any dataset, and thus allows for far more open-ended evolution, even if the initial images are less immediately beautiful. This process results in simple starting images generating their own sprawling evolutionary trees, blossoming into much more interesting images. Now, fundamentally, what is the point of all this? Why go through the trouble of evolving an image? The point is exploration. We are exploring image space. Imagine entering a colossal art museum. In it, a seemingly infinite number of unique pictures, paintings, and photographs hover in their place, stretching far above and far below, in every direction and beyond every horizon. Travel in one direction, and you find an area full of classical paintings. Travel in another, and you find pictures of cats. But most images look like this: random noise, static. You can actually visit this museum at the Library of Babel and walk through its seemingly endless hallways of randomness. This is image space, and it contains every artwork that has never been imagined, every photograph never taken, and every single still frame of your life and of my life and of lives that have never been and will never be. Every conceivable image. It is a literal mathematical space in which each image occupies a point or vector. But rather than having an XYZ coordinate with 3 dimensions, each point has as many dimensions as the image has pixels. Say we're looking at very low-res 32 by 32 images. With 3 channels for each red, blue, green component, we can calculate a total of 3072 pixels. Combined together, each image is therefore a 3072-dimensional vector which exists as one point in the space of all possible image vectors, which we call image space. With 255 possible values for each pixel, we can compute the total number of possible unique images. This is that number. For context, this is the number of atoms in the universe. Image space is inconceivably enormous and hopelessly unsearchable. You could look at 1,000 images a second for centuries and never find anything besides random noise. How can we possibly explore this space to find those beautiful unimagined artworks or exceptionally cute cats? Enter the text-to-image model. Be it Midjourney or Stable Diffusion, these models grant us an extremely powerful navigational tool: language. Like entering a query into Google's image search, you enter a prompt in a very easy-to-interpret human language that returns a vast array of possible images that satisfy the prompt. Text-to-image models, however, don't only return images that already exist, they can create entirely new ones. For this reason, they are often referred to as generative search engines. Within them, images are both created and discovered. The museum has been organized, cataloged, and labeled. However, text is not the only input to the model. We also give it a bunch of random numbers, which give the model variety, such that it won't always produce the same image for the same prompt. These random values make up the latent vector, which occupies a single point in its own space, a latent space. When a particular latent vector and prompt are fed to the model, it outputs an image specific to that input. You can think of the latent vector as the coordinates on a map that point to a corresponding image, and you can slowly change the image by moving about the latent space. This is how variations are generated. They are nearby points in latent space. Latent space literally maps to image space. In this way, the input prompt and latent values are like the genes of the output image, and your job is to search for the best genes. You do this by mutating, selecting, and reproducing the genes that perform best, whether it be the prompt or latent input. This is the pick breeder method of searching images, and it applies so naturally that, for the most part, people don't even realize they're using it when playing with these models. Now, maybe this isn't always the optimal way of finding the best images you're looking for. However, it is a very good way of finding the best images that you're not looking for. A fascinating and unintuitive discovery of the original pick breeder experiment is that very often the best images were found by people who were not looking for them. Simply by selecting the most interesting ones, they ended up following an evolutionary thread that created images they did not plan to create. This has far-reaching implications that will likely be the subject of a future video, but the same principle applies to searching with these text-to-image models. By simply following the thread of interesting prompts and images, regardless of what you originally planned on creating, you will often find much more than what you asked for. This is, I think, an advantage of evolutionary exploration. It encourages you to go down branching paths that eventually lead to unexpected beauty that you never intended to find in the first place. These models therefore serve as both our map and our ship on which we sail the uncharted latent seas. We are guided by the compass of interestingness, seeking undiscovered islands of beautiful images. I encourage anyone and everyone to join in this search and become a latent explorer themselves. These models are truly novel, powerful tools that extend your imagination and will only continue to evolve.